Now I want to talk about password attacks, and we're going to talk about John the Ripper, Hashcat, and credential stuffing. And again, some of you are already familiar with this, and this will just be a review. Some of you, it'll be new information. So, password attacks, passwords are insecure. People have been warned not to reuse the same password, to make them unique and complex, but people still use weak passwords, reuse passwords. It's one of the most reliable initial access vectors. It's been secured a little bit more in recent days through the requirement of multi-factor authentication and other methods, but there are still weak passwords on computers and accounts and everything. So offline cracking is where you capture the password hash through, say, exploiting a system with Eternal Blue and then downloading the SAM database, or grabbing the shadow file from a Linux system and using that to then do some offline cracking. This offline cracking, you can get a really powerful computer to go through it. You can run it on your home computer. You can run it on whatever you want. It just depends upon how long you want to take. It's also one of those where, since you have the hash, you can just take as long as you want. Nothing's going to stop you. There's online brute force or guessing, which is slow and noisy and could get the account locked out, could get your IP address blocked or something else. And so that's less likely. Usually, if you can grab the password databases or hashes, then you'll just do the offline cracking. And then credential stuffing is where you know that this user has commonly used this password or has used this password on this particular website, and then you try to use it on other sites and systems. And so credential stuffing, because, well, humans are repeatable, they have repeatable behaviors, it's quite likely that, especially depending upon the technical knowledge of an individual, they may have used the same password on multiple locations. So, password hashing, what's actually attacked? So, we talked about hashing before, where you just create the MD5 sum or SHA-256 sum, and that's the hash. And so what you do is you just have all the passwords, you calculate the hashes of that, and then you just check, is this hash the same as that? Is that hash the same? Nope. Just keep going through it. Hashcat's very good at that. John the Ripper will do that as well. Just kind of depends. Now, depending upon how the hash is stored, that may or may not work. So in old days, what developers did is they would just take the password, hash it with MD5, and then store that hash in a database. Well, that's relatively easy to bypass now. So now there's other things which are added onto it. So typically you add a salt into the password. So, and there's many different ways of doing this, but you can hash the password, then take a known password, add that onto the hash, and then hash that again. So now an attacker needs to know not only the hash, but also needs to know what was that added password which was added onto that particular hash. Sounds quite a bit more difficult, but in the case of, say, Linux, well, the shadow file has that salt. So you have the hash and you have the salt, and so you can go through it and still be able to compute those particular passwords potentially. NTLM, which is Microsoft's legacy hash format, doesn't use any salting. Identical passwords always produce identical hashes. So you can create what's known as a rainbow table, which is just a file of hashes of all the passwords. So there's dictionary attacks, and I'll talk about it more on the next slide, but dictionary attacks, which is just the file with, or a word list with all sorts of passwords in there. And then there is rainbow tables, which is you go through and you compute the hashes for all of those, and you store that in a file, and then you just run through that very, very fast. So what developers have done is to try to slow this down. They've come up with other mechanisms and other algorithms. So bcrypt, scrypt, and argon 2 are deliberately made to be slow. So in order to calculate the hash for a password, it takes quite a bit longer, and it is also salted. So an attacker would have to know, okay, what is the salt password? And then they would have to go through the process, and it's a slow process, to calculate the hash for a password. If that's not right, then they go through the same slow process again. So it takes quite a bit longer, and so that's why in this day and age, most developers should be using something like bcrypt just to prevent kind of the rainbow table lookups and pre-computing those hashes. So different attack types, and John the Ripper and Hashcat support these, but there's the dictionary attack. So there's a word list out there called rocku.txt, has 14 million real passwords in there. So I will encourage you to, first off, look at the rocku.txt file and look for your passwords inside of that file. If your passwords exist in there, you shouldn't be using those passwords. Because that means that they have been leaked somewhere and they are out in the wild. And it is a very common file for testing passwords, specifically for weak passwords. Then there's also rule-based attacks. So when you go to create an account or go to create a password, there are certain rules that a user would have to follow. So you have to have uppercase and lowercase letters. You have to have a number. You have to have a symbol. Some password systems won't let you have a number as the first character and only a letter. Well, that information will shrink your potential search space. Humans also typically follow certain patterns as well. So there may be a word in there. There may be maybe a couple of words and then a number and a symbol or something of that nature. So you can apply various rules to both John the Ripper and Hashcat to try to aid your method in guessing those particular passwords. There's the brute force method, which is literally, the simple letter or simple way is you start with A, then B, then C, all the way through Z, then you do capital A, capital B, all the way through capital Z, and then the numbers. And then you do AA, AB, AC, so on and so forth. And you're just going through every possible combination. This will succeed. I mean, if you have a 10-character password, it doesn't matter how many different letters and numbers or what combinations you have in there. Brute force, you will eventually succeed in guessing that password. It will take a very, very long time. Especially as you add one character, suddenly the complexity jumps up significantly. So brute force is not the best method unless you know things about the password. If you know that password is 10 characters long, well, then you don't have to worry about any password which is 9 characters or 11 characters. You're only searching through those 10 characters. So it's quite a bit faster. Also, if you know that it has a certain number of uppercase and lowercase and everything else, then you can narrow your search space significantly with that. And that leads into that mask attack. If you know what the password structure is, then you can build a mask for it. So in this case, and this all works with those two programs, you can say that it begins with an uppercase letter, then it has 4 lowercase letters, and then 4 digits. And that is very fast. So if you know that the password, so like my favorite password, blue1234 with a capital B, that would just be $U, $L, 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 and then $D, $D, $D. Then it would be able to crack that particular password. So you can kind of combine all of these, but generally what people will end up doing is they will start with the dictionary attacks just to see if there are any passwords which are common or words or phrases or something of that nature. They'll move on to rule-based attacks and try to find some that way. They may move on to brute force, but there is a point to where attackers just tend to give up because they'll find some passwords, and if you have a database of 1,000 hashes, for instance, they aren't going to try to find all 1,000 passwords. They will try to get as many as possible in a reasonable time frame, and then use those passwords that they have discovered to perform additional attacks and see what kind of access and authentication those user accounts will have. Because if one of those accounts happens to have administrative access, well, then they don't care about the rest of the passwords typically. They just only needed that one. So John the Ripper, it is a CPU-focused password cracker. It's a lot older, but it still works quite well. So you can just invoke it, and it's installed by default in Kali by just saying John, and then you can pass in the word list. I will say in the homework, which has you do this, the word list on Kali is compressed by default. It's compressed with the bzip2. So the first step that you have to do is you have to uncompress it using the unzip command. And once you do, then you'll have a text file there, and then you can run that. But you just basically use that word list and then the hashes, and it just goes through and tries to find out if any of those match that particular hash. If you wanted to use kind of their built-in word list and you wanted to auto-detect it, then you can just say John and then the hashes. That's it. If you have a specific hash format, then you can pass that in there. So if you know that the hashes that are stored in that file are MD5 or NTLM or something like that, then you can do that. You can also apply the mangling rules, so the number of uppercase, lowercase, that sort of stuff. You can apply those rules on the command as well. And then once you have it, the thing that John the Ripper does, and Hashcat does the same thing, is if you run it through the process and it finds a bunch of passwords, and then you run it again, it won't try those same hashes because it knows that, hey, those haven't changed. So what you would have to do is if you run the command again with a -- show, it'll show you all the passwords that it has managed to recover from those hashes. And so you can also convert a captured Windows SAM system. So what you would do is you do a SAM dump to capture the SAM, and then you redirect, and that's what that arrow does, to a text file. And that text file will be the hashes, and then you pass that into John the Ripper to try to crack them. Hashcat behaves similarly, but it's faster. It can use the GPU, so that means the computer and the virtual machine and everything would have to have GPU support. And it is quite a bit faster than using CPU-based tools because, well, GPUs are meant to do those kind of calculations. And so you can test quite a bit more than just John the Ripper. And these are examples of some of the commands. So that -m is going to be the hash type, and there is a command to list the different hashes out there. But 0 is MD5, 1000 is NTLM, there's a SHA-512 crypt, so on and so forth. And so you would just pass that in there. I don't remember exactly what the -a is. I'd have to double check and see. But you can just pass that in there. Oh, -A0 is a dictionary tag, that's right. And so then you would pass the hashes and then the dictionary file, and it just goes through there. If you wanted to do a brute force attack, that's that -A3, and then you can give it that mask if you know what kind of the structure is. And just like John the Ripper, you can show it with the -show, and that will show you all the cracked passwords that it managed to find. So kind of the difference between the two, John the Ripper is CPU-based, Hashcat is GPU, so much, much faster. John the Ripper can detect the hash format. Hashcat, you generally have to specify it, but it's not that difficult. And if you see the hash, you can usually identify what type of hash it is based off of its length. So John the Ripper is best for quick, small things, whereas Hashcat is much larger because it needs a GPU. Hashcat also needs the hashes extracted, whereas John the Ripper can read the shadow dump natively. Again, the homework assignment will have you grab the password and the shadow file and kind of combine them together, and then you pass that into John the Ripper, and it just goes right through it. And so you usually use John the Ripper first on a small hash dump, and then you grab what you can, and then you go through the much more computing intensive method using Hashcat. Credential stuffing, like I'd mentioned, you take those username, email, password pairs from a breach, which a lot of times they're public, and you try those on other login pages, other sites, everything else. So if you had logged into site A with a username and password that you also used on site B, well, site B can easily get compromised from that. So I will say that there are a lot of people that reuse passwords, and a lot of people that I personally know still reuse passwords, and it's very frustrating at times. So it happens all the time. But there are different tools out there that can test this, because one of the problems with credential stuffing is if you try all sorts of different usernames and passwords at a particular site, well, that's going to set off all sorts of red flags and is going to block that IP address. And so there are various tools out there which will rotate through proxy addresses and IP addresses to mask what you're actually doing. Again, don't do this in the real world. Only do this on networks and systems that you have authorization for. But there are tools out there which will make it so that it's a lot harder to get caught, or a lot harder to get blocked by trying thousands of different credentials all at the same time. And then different countermeasures, multi-factor authentication, rate limiting, CAPTCHAs, breach password screening. There's a lot of people, they should always sign up for Have I Been Pwned, because that will alert you when your credentials are found in a public leak somewhere. So again, when you're doing this in a penetration testing capacity, you're going to end up writing a report and recommendations as to what they should do. So the first recommendation, number one, should be multi-factor authentication. If the environment doesn't require multi-factor authentication, they should. It should be, in this day and age, that shouldn't even be an option as to whether or not to use MFA. It should just be everyone's using it. Because that prevents credential stuffing, brute forcing, doesn't prevent the passwords from getting out, but it's a lot harder for an attacker to use that password on the environment there if they require multi-factor authentication. Also, when doing this, you want to look and see, okay, how are these passwords hashed? And you want to make sure that whatever hashing mechanism, especially if you are evaluating a software package for security, you want to see, okay, are they being hashed through a quick hashing method, or are they being hashed through a slow one like bcrypt? And if it's a slow one, then that's good. If not, then they that should definitely go into the recommendation, is that a slow, more secure hashing method should be used, such as bcrypt. Make sure the password policy is sensible. So favor length and breach password screening, such as Have I Been Pwned, over arbitrary complexity rules. I've seen some bad complexity rules. Everything from there was one where the password had to be exactly 8 to 12 characters long, only letters and numbers, and it was very rigid, which is not normal, and it was for a bank. I've seen password policies which your password has to be 16 plus characters long, uppercase, lowercase, numbers, symbols, and it has to be changed every 30 days. Well, if that's the case, people are going to start to default into a simple password and then just change one character for each one. So it's really kind of a whack-a-mole at a certain point, but there should be sensible policies, things where nobody likes to have to change their password. And so trying to find ways to where users don't have to change passwords as often without compromising security is beneficial. And then you'll find users are more likely to choose longer passwords or choose higher complexity for that. You also want to rate limit and lock out, so accounts shouldn't be allowed to try to log in with the same password or different passwords thousands of times and not get locked out. That's one of the reasons why Microsoft RDP is so dangerous. Is Windows, at least older versions of RDP, did not have any rate limiting or lockout. So you could script and try to log into an RDP session with all sorts of passwords, and it wouldn't lock you out. It just would let you keep trying. And then you want to monitor for credential exposures. And there's a lot of sites out there which will aid with this. There's some dark web locations which will have those credential exposures. And again, Have I Been Pwned is a great resource that should be utilized by pretty much everyone. So password cracking, a lot of it's just guessing, checking against the hash. You aren't decrypting so much because hashes are one way. But if you know the process and you know the method, then you can say, okay, well, this is that password. There's dictionary, rule-based, brute force, masking attacks, and they all have pros and cons. Just kind of depends upon what you're looking for. John the Ripper is fast. Hashcat, or John the Ripper is easy and pretty quick to use, but is slow when you have to start doing a lot of computing, whereas Hashcat is quite a bit faster, especially for large scale. Credential stuffing, really bad, so people should try to avoid that, or should make sure that passwords are different everywhere. Use a slow, salted hashing algorithm. Bcrypt is one of the popular ones. And again, multi-factor authentication, most important thing that everyone should do. It should be required on every single system everywhere.